All right, so today we're going to figure out how to count the number of significant figures in a number. Those numbers have to be measurements, and something that we talked about is that all measurements are going to be estimates. And what we need to figure out is of a measurement, of a number, which of those numbers, which of those digits are significant to the actual value. What is important in terms of the calculation? How accurate are we? And which of those numbers is going to help us determine accuracy? So we're going to use the Atlantic-Pacific rule to determine significant figures, or sig figs. And just in case you needed a little background knowledge, the Atlantic Ocean is on the right side of the United States, and the Pacific Ocean is on the left side of the United States, just as kind of a background information. So the first step is you're going to write your number in the USA. You write your number out. And again, Pacific's on the left, Atlantic's on the right. So you have to ask yourself, every time you're counting sig figs, is there a decimal point present? In this case, we would answer yes, there is a decimal point present. So when that happens, what you're going to do is start counting at the first non-zero number from the Pacific side. So what we've done is we've drawn an arrow through the zeros, and we stopped at 5 from the left, from the Pacific side. So then we're counting 1, 2, 3, 4. So what you'll notice then is that we end up with 4 sig figs, or significant figures. We can also call them significant digits. And to show you another example, if the decimal point is absent, get it? A absent, A Atlantic, we are going to start from the Atlantic side, draw an arrow through all of the zeros, and start counting from the right. 1, 2, 3. So again, start counting at the first non-zero number from the Atlantic side. So in this case, we have 3 significant digits. Just the 4, this 0, and the 7. So we're going to go through a couple of examples together. How many significant figures, or sig figs, are in the number? So this one, decimal point is present. So we're going to start counting from the Pacific side. 1, 2, 3, 4. We have 4 sig figs. This question does not have a decimal point. The decimal is absent. So we're going to start from the first non-zero number on the right, and we get 1, 2, 3, 4. We also have 4 sig figs in this number. Notice the difference between the first number and the second number, because this has several more figures than this one, but they both have 4 sig figs, or significant figures. So there's a difference between just digits, regular digits, and significant digits, the ones that we actually care about. This one has a decimal point present, so we're going to start from the Pacific side, cross out all those zeros, and count 1. This one only has 2 significant figures. Decimal point present. Start from the Pacific side, the left. So we don't have any zeros in front, so we just count all the way across until we get to 5. And then the last one we did already, you have a decimal point absent, so you're going to start from the Atlantic side and start counting at 1, 2, 3. 3 significant figures. 3 numbers that are accurate to our measurement that we made. So just some kind of sidebar rules for sig figs. So all non-zero numbers are significant. So that's any number 1 through 9. Zeros that are between, I call these sandwich zeros, those are going to be significant as well. So if you have the number 101, the 1s are significant because they're non-zero, and this 0 is sandwiched between the 2 1s. So that 0 is also significant. The 0 that comes after a non-zero number and there's a decimal is going to be significant. So if you have 101.0, this 0 comes after the decimal, so it is significant. If we were going to use the Atlantic Pacific rule, we would start from the Pacific because we have a decimal point present, and we just count 1, 2, 3, 4. That 0 is significant. Zeros at the end of a number with no decimal present are not significant. So if I have the number 1,000 and there's no decimal point, these zeros are not significant. If we use the Atlantic Pacific rule, Atlantic means that we have no decimal. The decimal is absent, A and A, and this is our only significant figure. It's the only one that indicates the accuracy of what we know to be true about our measurement. So at this point, I'd like you to take a look at page 5 in your packet. We're going to go through a couple more examples. So it says, how many sig figs are in each of the following measurements? Put a star above each digit that you have determined to be significant. So we're going to practice the Atlantic Pacific rule here. Decimal point is present here. So we are going to start from the Pacific side, that's the left. And we start at the first non-zero number. Anything that's not a 0. 1, 2, 3 sig figs here. Now this one, we have a decimal present. So again, we're starting from the Pacific. But we have a 0 here, so we have to actually go all the way through to the first non-zero number. 1, 2 significant figures. That 0 doesn't tell me anything about the accuracy of my measurement. It just is a placeholder. Same thing with this 0. Decimal point is absent, so let's start from the Atlantic. 1, 2. This 0 just shows the magnitude, how large that number is. It doesn't actually give us any information about how accurate it is. This value could be anywhere between 340 and 349. So you have to be careful with that. Decimal point present here, so we're going to start from the Pacific. Draw a line through your zeros and start counting at your first non-zero number. We have 2 sig figs. Decimal point present, start at your first non-zero. 1, 2, 3. Same thing here. Decimal point present, start from the Pacific. 1, 2, 3, 4. These zeros just tell us how small the number is, that it's a fraction or decimal. We have 4 sig figs here. Start at the Pacific, start at your first non-zero. 1, 2, 3, 4. You count all the way across, even if you have zeros. So this is going to be also 4 sig figs. Now things can get a little bit tricky with scientific notation, and we'll talk a little bit more about this as we need to, but with scientific notation, this is just a way to show magnitude, show the size of the number. If it's really, really big, you'll have a positive exponent here. If it's really, really small, you'll have a negative exponent here. And in the past, I'm sure you guys have noticed that you are supposed to, if you have a positive number, you move your decimal 3 places to the right. If you have a negative 3, you would move it 3 places to the left. So we're only going to use the number before the multiplication sign to give us sig figs. You are not going to use the times 10 to the third because that's just placeholders. So there is a decimal point. We're going to go from Pacific, 1, 2. Now if there's no zeros in the number, you can just write down the number of digits because every non-zero number is significant. This one, decimal point is absent. Start from here. Start at the 5. 1, 2, 3, 4. So we have 4 sig figs, decimal point present. Start from the Pacific. We have 4 here. Decimal point present. Start from here. 1, 2, 3, 4. let me know if you have any questions, and we are going to complete page 6 for homework. Good luck.